Okay, so good evening, everyone. This is the mentor Hampeo Kliman, the head teacher at HC Learning Academy, an online school offering natural sciences in mathematics, physics, chemistry, and also biology. And of course, if you haven't yet subscribed to this YouTube channel, consider subscribing, hitting the like button, and don't forget to share to others. And of course, if you want to register for personal lessons, ensure that you inbox plus 26077 66 40 46. This is my WhatsApp number, and then I'll be able to register you upon payment. Just 100 kwacha each course monthly. Now we have a question here while under sound interference. They're saying two speakers are separated by a 5.0 meters and are being driven by a signal generator at an unknown frequency. Okay. Then they're saying a student with a sound level meter works out 6.0 meters and down 2.0 meters and finds the first minimum intensity. Okay, finds at the first minimum intensity after walking down by 2 meters. Then they're saying as shown, okay, below by the diagram. Then they say you find the frequency which is supplied by the signal generator, and then you assume that the speed of sound at that particular moment is 343. So now, look, the topic itself is called sound interference. And sound interference is simply where, suppose, let's say, you are producing two, okay, you have two speakers. Let's say you've got speaker 1, and then you also have speaker 2. Okay, then this speaker 1, let's say, is producing a song, which is simply sung by your maps. Okay, I'll give you an example of your maps. Then the other one, the other speaker, which we can call speaker 2, maybe is producing a song sung by Roberto. Okay, now if this speaker is producing a sound, let's say at a frequency of 20 hertz, and then this speaker is producing a sound, let's say at a frequency of let's say 15 hertz. Now you also understand that because the frequencies in terms of sound are different, you are going to you'll be listening to a sound that is going to cancel each other at some point. And depending on the amplitude and the frequency of the sound which is being produced, the one which has got a very higher frequency is going to cancel the one which has got a very smaller frequency. And at the end, what you're going to listen to is this particular sound. Okay? Is this particular sound. So if sung by Yoma. Now, if you haven't yet understood the concept of sound interference, it's very important you reach out to the HC Academy store and get a lesson video on sound interference so that you really understand what we really mean. Okay? So there's going to be a disturbance, and the disturbance is going to cancel in terms of wave motion. By cancelling each other, you are going to listen a very smaller sound which is going to be sung by musician 1. Okay, that's how it works. But let's say suppose you have this speaker 2 is also producing a song which is sung by your map, the same song, but except this time around you've reduced on the frequency. The other one has got a higher frequency. Regardless of the differences in frequencies, there is going to be cooperation in terms of sound waves. Okay, there will be cooperation in terms of sound waves, and at the end of it all, because of that cooperation, remember it's the same voice, it is the same sound, except one is lower in frequency, the other one is higher. The two will not cancel each other, they will not subtract, they will add each other. So it's going to be a 20 plus that 15 hertz. So collectively together, you're going to produce something like 35 hertz. So you are going to hear a very loud sound. Why? Because there is a cooperation in terms of sound waves that are being produced. That is what we call sound interference. It's a very simple concept. Now, for this particular question, I want you to see something. Remember that you are producing sound from this particular speaker, and that sound is traveling a distance from here, where it's being produced, up to here. This is called the path length. Okay, even this side, it's called the path length. Now, the question is saying, after reaching here, this guy could get a first minimum intensity. Okay, now your first distance is 2 meters in the vertical. Okay, so you do this. Then your second distance is 6 meters in the horizontal. So you get your 6.0 meters. Then this is going to be your 2.0 meters. Okay. Then here is your path length. Okay. This is going to be your path length, which is equal to R. Let's say R1. Okay. The second one is still going to be the same thing, like this. Now, because this is 2 meters, this is 5 meters, but we have been told that from this point to this point, it is a 2.0 meters. Meaning from this point to this point, it is a 3.0 meters. So this is going to be like 3.0, like that. This is going to be our second path length, and we can name it as R2. Now we all know that when you're doing sound interference, I taught and I mentioned that find your R's first. So R1 is going to equal to square root of, because that is Pythagoras theorem. So it's going to be a 2 squared plus a 6 squared. This is basically what we have. Okay. So this is going to be like R1 is equal to root of, this is going to be 4 plus 36. So we're going to have the square root of like a 40. Then we get the square root of a 40. Square root of 40 is actually 6.3. So this is like 6.32 meters. We also get our R2. R2, we use the same concept, except we are using 3.0. Use the same concept I'm giving you for any question. You are using the same path length. R2 is equal to square root of, this is going to be 9 plus 36. R2 is going to equal to, so it's a 9 plus 36 is going to be 45. Okay? Then you find the root of 45, you're getting like a 6.708 meters. Now remember that I mentioned that sound cancels each other as it keeps on traveling. These are speakers. You are standing here. If these are of different frequencies, they will cancel at some point, and you might listen to a small voice if the sound waves are not cooperating, or if the sound is being sung by two different individuals. Okay? But if it's the same sound sung by the same musician, but different frequencies, the frequencies will cooperate, they will add each other, not cancelling. And you'll hear a very loud sound. So, the two are going to cancel each other at some point known as the path length. So I'm going to say your path length path length is just your R2 minus your R1. What is R2? It is simply 6.708 minus R1 is 6.32. Then you do your subtraction, you are going to get something like 0.388 meters. Now, remember what this question is saying. Very interesting. It's saying, after this person, this guy, when he walked down the 2 meters, he finds his first minimum intensity. So for the first for your for if you want to find your access in relation to the wavelength, your first in your intensity, right? Okay, or let me say, if you want to find wavelength for sound which is not in cooperation, okay, or a disturbed interference, okay, then you consider your path length equal to your wavelength over your 2. This is very important formula. Okay. Now from there, okay, this is for disturbed interference. Okay. Not cooperative but disturbed. That's how you are able to relate your path length to your wavelength. So this is going to be like a 2L is equal to wavelength. Then you get your path length, you put it there. Okay. So this I taught at HC. And your your wavelength is going to be like 0.776 meters. Now you know that your frequency, so your velocity is equal to frequency multiplied by wavelength. So over the wavelength, your frequency is going to equal to like the velocity over the wavelength. What is velocity? It is 343 over 0.776. So 343 divided by the answer, you get like okay, let me check properly to ensure that we are really getting something. So 2 multiplied by 0.388. Okay, it's like 0.0776. Okay, then this is going to be like 343 divided by the answer. Divided by the answer. Just a minute, let me. Interference. Okay. Then this is going to be multiplied by 2. Then 343 divided by the answer. Okay, this is going to be like your frequency. Frequency is going to be like 442 hertz. Okay, basically this is how you're supposed to answer such a question. Okay, so basically that's how you're supposed to answer this particular question. Okay, let me. It's actually very simple. If you found this video interesting and helpful, make sure that you subscribe and hit the like button. Don't forget to register for personal tuitions. You use this concept for sound interference, for any question that they give you under speakers.